Hey, back for video 2, free response section. A new drug to treat senioritis is going to be tested to see if it will reduce the laziness in the population of seniors. A random selection of seniors are selected, with half receiving a placebo and the other half actually receiving the experimental drug. Early indications suggest that the effectiveness may depend on the student's weight and gender. Draw a graphic or a flowchart of how you would perform the experiment without blocking. So you're starting with randomly selected seniors. Half of them are going to get the placebo, half of them are going to get the drug. You're going to compare for effectiveness. That's all this is asking. The second one asks how you would form the treatment and control groups if you wanted to control or block for gender and weight. We're still starting with random seniors. Now, you can either go placebo, drug first, or you could start the blocking. So placebo, drug, then you're going to start with the blocks: gender male, gender female, gender male, gender female, and then further go for weight. Maybe small, medium, large, small, medium, large. Remember, these are people, not fries. Small, medium, large. Now, if you just did small and large, that's fine too. It doesn't specify. But at the very end, go ahead, compare treatments for effectiveness. Another way that this question could be phrased is, how many treatments do you have? And that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have comparing 12 treatments. Number 12. A town is proposing a property tax increase to update a dilapidated school. While wondering if it will pass, they decide to randomly poll voters. Describe what type of sample is being taken for each. A. Obtain an alphabetical list of all potential voters in the town and number each potential voter. Use a random number table to select 50 to ask how they would vote. Ignore repeats. That's a pretty basic, simple random sample. B, go to the local grocery store and ask everyone in the checkout line. That's a mini census. You would think that that line is representative of the bigger population. It would be a cluster sample. Go to the local grocery store and ask every 12th person who is entering the store is systematic. D, ask some people you know in the town. That's probably somewhat a convenient sample. E, take a random sample of people who shop at Dollar Tree, Walgreens, and Whole Foods. That would be a stratified sample because you're taking an SRS of each of those, and you would think people who shop at Dollar Tree are going to be a little bit different than people who shop at Whole Foods, who are a little different from people who shop at Walgreens. Different being they have different opinions. And F, what problem or bias could come from only sampling the people at Whole Foods? That's an example of undercoverage, because it's going to overrepresent the people in Whole Foods and underrepresent the people who shop elsewhere. 13, a group of students is investigating opinions on campus about the U.S. military. They randomly select a group of 100 students on campus and ask them one of the two following questions. A, do you think transgender people should be allowed to serve in the military? Or B, do you think that transgender people should be provided an equal opportunity to serve and protect their country? Which question will elicit greater support for the inclusion of transgender people in the military? That's clearly B. And what kind of bias? You could either say this is the response bias, which is also known as wording bias. And last one. As a Halloween treat, Mrs. O'Connell made a very large batch of caramel apples to give out to trick-or-treaters. Mr. O'Connell, however, made a caramel-covered onion to mix in with the apples for one unfortunate trick-or-treater. We leave out a tray of 9 apples and mixed in the onion randomly. Describe how you'd use a random number table to conduct a simulation for how many treats the O'Connells have to give out until they expect someone to take the onion. So you're going to assign random numbers zero through 8 to the apples, and 9 is the onion. Record how many apples are taken before the onion, then, not then, ignore repeats. It pauses. All right, let's finish this up. So here's the table. We're going to look at single digits. So 1 is an apple, 5 is an apple, 8 is an apple, 9 is the onion. How many treats? 1, 2, 3, 4. And we'll count the onion with it. Right here, 5 was an apple, 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 repeat, apple, 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 repeat, repeat. Here, we'll apple, 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 apple. And I tripped myself up just a second, so let me explain what just popped up. So I labeled all of the apples in green and all of the repeats, which I'm just ignoring until I got to that apple. So that's 1, 2, 3, 4, 5, 6, 7, 8 apples, 9 when the onion was taken. On that third one, you see apples and repeats, and it was the very last one taken at 10. How many should we expect? Take an average or something. 4 plus 9 plus 10 over 3. 23 over 3, or about, say, probably about 7 or 8 apples until getting the onion.